brought his fascination to snakes and love of adventure into a very different level. I think one unique Sri Lankan role model, not just in Sri Lanka but across the globe, especially in Australia. He do a lot of like family, like how to do science with kids kind of stuff. Actually, in fact, I wanted him to do something like that today, which kind of I forgot to tell him, and anyway, but he'll be talking about some of the adventure, high-end science that he do. And Ruchira is no stranger to Sri Lanka. He just published. He had I think the big book on snakes in Sri Lanka, and he had the singular translation, singular version of it yesterday. And that book copies are here. Yeah. So if you wanted to purchase, he will have that reduced, price, pre-publication price. Available here after the seminar. Anyway, I don't want to do the seminar by myself. Introducing, so it's Ruchira Somavira, an undergrad from Peradeniya University, done his PhD in Sydney, University of Sydney. I'm not reading his bio, I'm just trying to remember what he said and my interactions with him for the years. And Ruchira, as I mentioned, he worked for the CSIRO, the kind of the big science body in environment and wildlife management in Australia, and then he worked as an adjunct prof at the University of Western Australia, as well as he has his own company, like a high-end tourism company as well, getting customized adventure wildlife photography and observation based tours in Eastern Asia. Yeah, I think there's a lot, and the most important thing something that I really like, Ruchira is he's an explorer, and he's a prominent a personality in science in Australia, and he's a National Geographic Explorer, where he inspires kids through his science. He inspires people like us through his science and his capacity as in varied skill sets, from art to photography to his presentation skills. So in that light, Ruchira, I hope that you can spare a few more, for about half an hour or an hour after this session, where students can talk to him and we'll go to the museum. We have a museum and a boardroom there. Among specimens, we can just spend a little bit more time with some food. All right, I think that's a very informal introduction, but thank you very much, Ruchira, for coming here, and floor is yours.
Always a pleasure to be back home and sharing my passion, and hopefully will inspire or give you some tips of what we are doing and how those things can be implemented in Sri Lanka. So any research students or any enthusiast, any naturalist, anyone who has a passion on nature, wildlife, I hope I leave you with some ideas and some inspiration to continue your journey. Let's go on a journey. Our journey starts a long time ago, about 35 years. I have, since I could walk, I have been interested in things that can hurt me or kill me. So while people like Sampath were and still are into the cute and cuddly and fluffy things, I found amazement in the scaly, the creepy, the crawly things. Right? So reptiles became such an integral part of my childhood. And that passion, that hobby later became a passion. I think I lost my mic. Can you still hear me? Oh. Later became a passion and a career, and now it's almost a lifestyle. Right? Now, this was not hard growing up in Sri Lanka because it's a global reptile hotspot. So this is the per area reptile diversity in the world. So the red spots are where you have loads of reptiles to play with. Right? So as you can see, Sri Lanka is well and truly in that space. So there were plenty of things to play. But what I'm going to share today is how that childhood passion has become a career and what we do in actual science to better understand these reptiles. Specifically in global change context. We'll come to that. Now, when I say what I do, it's not necessarily me, it's a whole bunch of people. So let me first put a big thank to all those people, family, friends, colleagues, students, and all these people for money over the years and currently supporting my work around the world. Let's zoom out from Earth. Who has seen this photo? Has anyone seen this photo? Does anyone know what that is? No. So can you see that tiny dot? Like there's a white dot there. This is the this photo was taken by Challenger. This is the photograph that has of Earth that has been taken from the longest distance. Right? That's the actual photo NASA released of Voyager taking it just past Jupiter. So when you think of like a universe context, we are nothing. Like the Earth is just a speck. Right? In fact, this photo is actually called the blue speck. To give the context that we are so small, means nothing. Right? However, when we get closer and closer, you see Earth. And this Earth is changing. As far as we know, according to any reliable science, this is the only place with life so far. Intelligent or stupid, it is the only place with life. Right? So, but this place is changing a lot, and I have a huge interest in understanding how these changes are affecting our environment, especially reptiles, and what we can do to better understand that and implement and use that scientific knowledge to help animals concerned. So that is the basic theme of all my research, how animals adapt to a changing world. But within that, I have quite a few different lines of work. So we'll go through some of that in chapters. So we'll start with invasive species. What is an invasive species? What's the single term for invasive species? ආක්‍රමණශීලී විශේෂ. Oh, you can talk, right? අපි මේ සාකච්ඡාවක් වශයෙන් කරගෙන යනවා. ආසනයක් කතා කරලා ගන්න. So let's do a discussion, right? ආක්‍රමණශීලී විශේෂ. Huge difference between an invasive species and an introduced species. We have millions of introduced species in the world, but only very few invasive species. Just because we introduce a species does not become invasive. Invasive is when it's actually affecting the local systems, right? So that invasive species have been a big interest of mine over the 15 years, the last 15 to 16 years. Specifically in this part of the world. This is the Kimberley outback, one of the most remote parts of the world, right? Api Lankawe Dushkarai කියන පැති, they are not Dushkarai, right? Here you can all of work on choppers because there's no roads. You have to have a helicopter access to go to your field sites, and even then you won't see humans for days. You can travel for hundreds and hundreds of kilometers without any sign of humans, right? It's that remote. If you walk in these places during the wet season, you hear that sound, right? You heard that sound, right? So that sound is these guys. This is baby crocodiles calling from inside the eggs, right? So when baby crocodiles are about to hatch, they call from inside that egg with that sound. And that signifies the parents to come and dig them out. Right? So an aspect a lot of people don't know. Baby crocodiles tell their parents when they are about to hatch, so help them get out. It also synchronizes hatching. Right? So it's telling, okay, I'm about to go out, come and join me, let's go out together. And why do you think that is?
For protection.
For protection, right? If one by one comes out, it's very easy for predators to pick them up. But if 50 comes together, the chance of surviving, few of them surviving, is high. So nature is amazing. So studying these guys has been a huge part of my career. And that's Bill, my field assistant for about 10 years. We have been going full outdoor, like full outback into the most remote parts of Australia, catching these guys and learning about them. And that's a big crocodile for that species. So that species is Crocodilus johnstoni, Australian freshwater crocodile, and that's an adult species, adult specimen. And you should never wear white for field work. So our work has shed a lot of ecological insight for these guys. For example, we now, because of our work, we know how they coexist with other predators like these freshwater sawfish. one of the largest fish in the world, freshwater fish in the world. They eat each other. We were studying how top predators coexist in a space. We looked at how they hunt at night, right? They are hunting, sleeping, all of these sometimes. So how they do that, why they do that? How they look after their babies. So you can actually see that there's a mummy crocodile and there's quite a lot of babies around them. So the moms will look after the babies for months. No other reptile do that, right? Reptiles would eat their own babies if they want. But these guys look after their babies for months. What are the aspects of parental care? That has been a significant part of our work. There are unique populations of crocodiles that live inside caves. Right? Now this is puzzling because crocodiles are cold-blooded animals, meaning that they need warmth to activate. If you are living in a cave, that's cold. Right? So how do they do that? And we find that geothermal energy, or the heating of the rocks and the heating of the water inside because of the rocks, is actually enough for these guys to function. So that's a very unique population. I have been studying what eat crocodiles. We know a lot of things about what crocodiles eat. They eat pretty much everything. But I was curious to understand what actually eats crocodiles. So we have been studying those guys. And finally, the more like the better how the mummy crocodiles help the babies hatch. Now how gentle a big crocodile picking up egg at a time, chewing it, getting the baby out and carrying them to water one at a time. Right? So these are not aspects that we normally think of a big predator. And ecology has been that has been my heart. Like I want to understand what these guys do. While I was studying these guys, these toads turned up. Now I gave the same talk at Young Zoologists Association yesterday, and I know that some of you there. Do you know this species? The cane toads, right? So basically, there are frogs and toads. Medios are gembo. Australia don't have any toads naturally. What is a toad? Is it a gemba or media? Media, right? So no media in Australia. Plenty of gembo, right? So plenty of frogs. But toads make special chemicals, especially on their neck. There's a gland called the parotid gland, which has a kind of a cocktail of toxins called buphenolatids. And when predators eat them, if they can't handle those toxins, they die. So given that Australia never had toads, the native Australian predators, including crocodiles, never evolved to be able to digest these toxins. So when these guys were introduced to Australia as a biocontrol agent, so Australia had an issue with sugarcane, ukwagare, and there was a beetle. They looked at, what eat this beetle in their native range? They found these dudes. They brought them up and now they are killing everything, right? Now the problem is that they don't come in one at a time. They actually come in hundreds and thousands. They are extremely common. Like around water bodies, you can see the ground moving. They are that common. Now, these guys, when I was studying crocodiles, they were invading one of the most unique, beautiful places in Kimberley. One of my favorite places to be. This is called Ninjana Gorge. Now, may lights off or soft current. Oh, sorry. Okay. So, unfortunately, you can't see it well, but this is a beautiful place in the middle of nowhere. It's a very dry area, but then you have an amazing waterhole surrounded by massive rock cliffs, right? And a unique population of crocodiles live there. So we knew that if the toads made it there, they are going to die. But I wanted to find out how these things impact, because we didn't have any knowledge. It's very easy for people to say, right? But that's not based on any science in most cases. It's things that we think is happening, right? So we want to actually find out scientifically what is going on there. And to find that, you need before and after. Any good ecological study needs before and after. And not just 1 year, many years before and many years after. So you can actually see the patterns. So we started, I put a team together, my students, rangers, some of the Aboriginal traditional owners from the area. So this is my mini team. So we started, 7 years ago, we started Western Australia's only mark and recapture study. So we go there, catch all the crocodiles in this waterhole, about 130 of them. All these crocodiles are tagged, they are marked, we know exactly what size they were, what weight they were, whether they were reproducing, how many eggs they carried, because every year we have been measuring them, marking them and checking how they are doing. We have an amazing data set now to see how how this population fluctuates naturally. How much do they grow? What are the size classes in this population? This kind of information is essential if you want to find out what the impact of something is. We didn't stop there. We actually expanded this study to a much larger area. Now, just to give context, my study area is about 3 times the size of Sri Lanka. Right? 3 times the size of Sri Lanka. So it's a massive area that we are studying. Right? These rivers are longer than the length of our country. Some of these rivers, like especially Victoria. So the scale of this work is something beyond, right? And it takes a lot of people, a lot of time to gather this amount of data. So we have been studying a lot of things like mortality, how cane toads are killing them, genetic resistance, certain populations can be naturally resistant to certain things, how that works. What are they eating? Right? Because some populations are unique, they only eat certain things, fish only, right? If you are not eating frogs, chances of you eating a toad is less. So let's focus on something that actually eat more frogs, that are more likely to eat toads. So this is how you study stomach contents. So you can, in smaller crocodiles, you can scoop them out. Bigger crocodiles, you put a garden hose and you have to pump it out, right? So if you get really drunk and go to a hospital, they do this to you too, right? So it's no different to that. So, okay, so now over about 10 years, we have this massive data set showing what size crocodiles are most impacted, how they are impacted, and what level of impact is possible, right? Now, a huge knowledge gap in a lot of ecological research is that we have all this data, but we don't then go to the next stage saying, so what? What can we do to help the species from the knowledge we have? So we went to the next level and we wanted to use the knowledge we have to actually come up with a system to help these guys. So in this case we did cafeteria studies, so these are keeping crocodiles in the labs and feeding them different things, and we found out that if you give a small toad instead of a big one, they get sick but not die. And they learn not to eat anything that smells or tastes or looks like that in future. It's called taste aversion learning. We do the same. We don't eat again, right? It's common sense. So these guys do the same. What we find is that after about two encounters, they hardly catch anything. If they see something or smell something like that, they'll move away. Right? So what we did is we created a whole bunch of sausages using cane toad meat. So when I say sausages, this is not cruelly catching an animal and grinding it, right? So Australia has one of the highest levels of animal ethics approval and research ethics. So under a lot of standard practices, we get the meat of cane toads, turn them into sausages, get into a chopper, and we put them in front of the cane toad movement. So the cane toads are now invading the country from east to west. We are dropping these in the landscape before the cane toads come. And the idea is that animals in those landscapes will eat these, and they have already learned not to eat something that tastes or smells like that when the actual cane toads come. Right? So using taste aversion learning as a way of teaching animals. One of my honor students, Abhi, also created this system that we can actually feed sausages to crocodiles, and it showed very promising results. Very little mortality in the water holes with trained crocodiles compared to untrained crocodiles in other water holes, right? So these are ways where you can actually use your knowledge, the ecological knowledge that you get, to actually have better outcomes, better conservation outcomes. That is something Sri Lanka desperately needs, especially in the herpetology field. right? We have a lot of, we have knowledge, but it's very important to turn that knowledge into conservation and management actions. Now, the invasive species doesn't need to be animals. You can have these guys, right? Lanka Padadalviani, right? Passiflora fodita, it's a wild passion fruit. Now this is a South American plant that has invaded most part of Australian outback. They love growing close to water, so they have like chock-a-block the banks of river systems. And the problem is that crocodiles need open areas to nest. They don't like, if there's a lot of vegetation, they don't clear and nest. They need plain areas to lay their eggs. So when it's all covered with weeds, they just go and nest in places that are not suitable. The other thing, they also have temperature-dependent sex determination, meaning that their sex is determined by temperature at which their eggs are incubated. In humans, how is it determined?
X and Y chromosomes.
Yeah, it's chromosomes, genetics, right? So it's something to do with genetics, right? So in us, whether we are a boy or a girl is determined by genetics. In crocodiles and marine turtles, whether you are a boy or a girl determines on the incubation temperature. So when plants grow over nests, it changes the temperature profile. Some of those eggs don't hatch, some are just one sex. There's no sexual balance in those populations. So I wanted to find out how these plants are affecting, how much shade is there, how much area is it covering, and use that knowledge to model and do a viability, they're called viability studies. You can actually model how many crocodiles would survive in 10 years, 15 years, 20 years time, right? To do that, we got a very fancy tool. It's called a LiDAR drone. $250,000, so $250,000 for this drone. But what it does is that, so I can fly it, it's fully automated, it will go do its job and give me an amazing amount of data, a 3D model of my site, right? To the level, I can calculate the surface area of all the leaves in my site. How many centimeters of the ground is shaded? How many plants are there with a diameter of more than whatever, right? So this level of, like a 3D model like this, which is actually quantifiable, meaning that I can do measurements. So using these, we now have models to tell, okay, if we clean up this much space, because you can't clean everywhere, right? But now we can model, if we clean up this much space, we can increase the breeding by this much. And we use that model now to actually manage this habitat. Like the wildlife rangers do a cleaning project, but we understood, okay, these are the best areas to clear and we only need to clear like a 10 by 10 or whatever. Right? But that information can be only gained from studies of this nature. It's very hard to do this on ground, right? But now technology exists to do this in a very easy and a more effective way. I wanted to do the same in Africa, so I went there to Kruger National Park in 2019. Unfortunately, because of COVID, we could not get that done. Polisinyo Marankian, right? Eva ge gahak tiyena me Africa wala hadena ekak Confront River කියන එකේ. So that plant is affecting Nile crocodiles. So we started a project, but we actually could not get that going. But in Sri Lanka, it's no different. Right? I have a paper that, so by the way, all these papers are on my website. If you go, you can download all our publications for free. So that's a mugger, halakibulek, right? As you can see, it's all covered with Japan jabara and other invasive plants. We don't normally think the impact these kind of invasive plants have on large predators, but they do. We have actually done, I have a review of direct and indirect impacts of vegetation on crocodilians. And you can see, including in Sri Lanka, how many species can have like indirect effects from these plants. Now, the most important part of research is that research will actually tell you whether we should do something or not. Right? A good example is that a few years ago we started a project in one of the most beautiful parts of the world I have traveled to. That's Ashmore Reef. It's in the middle of nowhere, between Australia and Indonesia. And it's such a unique place. It takes 2 days, 2 full days on a boat to just get there, overnight, right? And the Hemidactylus frenatus, right? So those guys are now have invaded that island. It's the only land vertebrate in that island. So the Australian government sent a team of us to find out how many are there and what to do about them. So we did a lot of analysis, like what are the interactions, what amount of insects do they eat. So we killed a whole bunch of them, did gut analysis to do a model of how many insects are being taken out by these guys. So after all this analysis, we came up with an idea. You know what? They are there, they have an impact, but there's not a practical solution to control them, right? Controlling geckos in wild are extremely impossible. There's not a single example from around the world that it has been done successfully, because the damage that you will do to that system to get those geckos out is more than the damage they do themselves. Right? But only proper scientific studies can tell things like that. So another reason why ecological studies are so important. That leads to our second chapter about habitat change. Now we talked about invasive species and some of the work we do. Another interest of mine is habitat change. It's another way our world is changing. What's this place? This is in Sri Lanka, by the way. Knuckles, right? This Pitol, just south of Pitol. Now Knuckles have a pretty awesome animal. Well, they have a lot of animals, but this dude, what's that? Oh, come on, speak up. What is that? It's a horn lizard, but which one? Leaf horn lizard, right? 74 So there's 6 species of horn lizards in Sri Lanka, and these guys, unless Mendizaya has another one coming, these guys are endemic to that part of the world. Now, one of the biggest things, if you look at a lot of literature, it will say that Enasalvaga, cardamom, is harmful for this species. It has been used over and over and over. I'm one of those people who do not believe just because something is said. I want to actually find it myself, right? So I just don't see the logic how cardamom can affect this species. So we ran a proper scientific study of understanding what's the habitat use of these guys, right? And what we found is that when you compare pure cardamom plantations to mixed cardamom plantations to natural forests, you actually see a significant high number of these guys in mixed plantations. Now cardamom is one of those things you need a canopy to grow because it needs shade. So in most places it's done as an undergrowth. And there's multiple reasons. There's more food because the cardamom flowers attracts a lot of insects. There's also more perching because they are all vertical stems. But cardamom actually does not affect this species as we think. Cardamom has a lot of other problems, like obviously it's harmful for the environment, but this is not a justification. So sometimes habitat change does not necessarily affect all species. Some species get advantage, some species are neutral, some species are negatively affected. So don't think that just because of habitat change, everything's going to die, everything's going to go doomed, right? It's not the case. Nature is way more resilient than that. We took Martin Whiting, one of the world's leading scientists on lizard color changes, and he experienced his first Udella, and that's Raju. He cooks the most oily body, but he has the white fat t-shirt. So Marina ran a project understanding how habitat change affects the coloration and communication of these lizards. Now these guys communicate with UV inside their mouth. You can measure that from a spectrometry. So we did one of the first field spectrometry studies on lizards, understanding how these guys, when habitats change, when the color, like when a forest opens up, when the light conditions change, how these guys adapt to that. So these kind of studies are done around the world now, better understanding how animals change. And this is very common phenomena, even in Perth. We live by the ocean, close to the ocean, and the places we go, our like most popular place to go, have these dudes. They are called king skink, one of the largest skinks in the world, Igernia kingai. That's not me feeding one. That one crawled over me and was battling with a pizza on my plate. Right? They are that bold. There are reptiles who actually love change, and this is one of them. These guys thrive much more in disturbed habitats around humans than in natural places. So I got one of my postdocs, James Barr, who's also an MMA fighter. He loves beating other people and also small skinks. We got him to study the interactions of these guys in different habitat conditions. So we put some unique trackers on them. They're called proximity trackers, right? So what they do is that when you put enough of them out, you can find out which animals in the population interacts with which animals. So every time two lizards come close to each other, it records it, right? These are called social networks. So we can see that the animals in the around are so shy, they're polite. Right? They don't like other animals. Whereas the ones in the middle are like, oh my god, the social at best. They just want to talk to every other skink. So understanding these kind of things gives you us insight as to how animals are now living in a like their social structures change as habitat change. Now this information is important because we think that, alright, that thing is affected because now it's living in an unnatural environment. It's not the case. That is a very old school way of thinking. We even took it to the next level and we studied how the physiology of reptiles change when habitats change. Right? So we looked at tail damage. Tail damage is a way of measuring survival rates in reptiles. So tail damages can be classified, and we looked at the ecological impacts, how tail damages change with gradients. We also found something quite new in science, that in highly disturbed areas, you have regeneration of tails in lizards. So when a tail breaks in a lizard, the regrown part does not have bone, it only has cartilage. Cartilage rod, right? As you can see from that, so this is a CT scan of a tail. But we can now, for the first time, we know that if that breaks again, it can grow too. Right? That was not known before. We thought the cartilage can only grow once. Right? But we see these kind of regenerations in animals living in like disturbed environments more. So not only ecologically but physiologically, these things change. We went another level up and went to Komodo. I love Komodo. Naomi and kids were recently with me in one of the trips. It's one of the childhood dreams since I saw David Attenborough's like 1970 Zoo Quest, where he goes and catch one of these. I always wanted to work there, and it's such a cool species to work with. And we were looking at how these guys have adapted to a change, because this is a massive lizard living in a small island. Right? How have they survived? All the other megafauna has gone extinct. Why and how are these guys surviving? The only two big animals that live in small islands now are the Galapagos tortoises and these guys. So it's another part of our work, understanding how big reptiles survive in a small space. Now, sometimes living close to humans is not a cool thing, right? Now this is a dugite, a brown snake, one of the world's most venomous snakes, and they're very common around houses in Perth where we live. So what we want to find out is that, okay, when we catch a snake and put it somewhere else, what happens to it? Now in Sri Lanka too, there's so many people, and with very good intentions to save the life of reptiles. A snake, when it comes to your house, you catch it and you go and put it in a nice place, right? We almost never think what happens to that snake when you put it in a new place. So we wanted to find that out, and we put some GPS trackers on snakes. Putting GPS trackers on snakes is really hard because you need to actually surgically implant them. You can't put them on the snake like in a lizard. So we did it under anesthesia in the lab, and we relocated them. And what we find is that the further away you put a snake after catching, the higher chance it's going to die. Right? This idea that snakes want to live in pure wild places, again, absolutely no scientific basis. If you find a snake in your home yard or your university like campus, that's because that snake wants to be there. Right? There are conditions for that snake that it's seeking. So when you put snakes away from where they are caught, their behavior got so increased, their activity gets so high, they are trying to find their way back. Almost all of them died. Some of them died from road accidents, some of them died from hunger. So because we can track them down, we found the carcasses, we cut them open, there's nothing in them. They don't even eat, they're just so worried of getting home. Because for a while we thought snakes don't have a home, they are nomadic, they just go around anywhere. It's not the case. They have a home that they want to come back to. It's called homing, right? And no animal do this better than crocodiles. Around the world there has been many studies of how crocodiles are homing. What happens to a crocodile when you put it in another place? For example, in one study, Steve Irwin actually caught the crocodile for this study. A croc was caught in that place where it's a capture, taken from a helicopter to the other side of that peninsula, put it in another river. That crocodile came down the river, went up and down the river mouth, found that it has to go around the peninsula, took months to find its original river, came up the river and found in the same waterhole again, right? Now we know that translocating crocodiles is absolutely meaningless. So in Australia, when we catch crocodiles of this size, you either euthanize them or you put them in farms, because translocation is an absolutely useless thing. So whenever you hear in media here that a crocodile from Nilwala was caught and put it to yard, that crocodile is almost all dead. The survival rates are extremely low. Or in no time, in over the months, it will find its way back. And that has been shown in a much larger area than Sri Lanka. So it's no doubt is happening here. Right? So scientific studies give you the insight to rethink that, okay, what are we doing? Are we doing something that actually science backs or not? Right? So that's why ecology is such an important thing. Now, I got some money from Chicago Zoological Society a few years back to put kibul corridor. So this is before the government did this project. And the idea was to provide a solution to the crocodile-human conflict by providing a safe place for people to access water. This was an utter failure. In a couple of months, all these were sold for metal. Right? So none of these existed. Right? The villagers themselves sold the metal, the mesh and the pole. So unfortunately, it did not work out. But back home, we are trying a couple of new systems. We are trying a way to detect crocodiles in murky waters before they come. And because most waters is like here, right? If a crocodile is under there, even if it is a whale under there, you won't see it. Right? Because that's so murky. So we are trying to test sonar systems like this one. So what this is, that's one of my students on a plane. That's one of the bushmen with a stick which has two cameras at the end. One a GoPro, the other one is a sonar camera, right? So what you are seeing there in that photo, in that video, is when you put the two cameras in. That is the normal camera. As you can see, it's just murky, you see nothing, right? But when you look at the sonar, you can see 3 crocodiles within 2 meters of that camera underwater. There's one moving, the other 2 are just lying on the bottom. Crocodiles can stay in such shallow water without being detected, and that's a huge reason why crocodile attacks are common, right? Because they can approach you in such shallow water without giving any sign. So now we are testing whether we can develop with Queensland Parks and Wildlife Department. We are testing whether this technology can be developed into a warning system. Whether we can install some of these in bathing places, so whenever something big comes, it actually runs an alarm and people can get out of water. We have been trying other systems to detect animals underwater, especially sea snakes, which is another huge interest of mine. I have that very cool toy. It's a ROV, a remotely operated vehicle. That it's pretty much a drone that goes underwater. Is it my backup? So, but it's not very effective because it actually scares off animals. So we then started using BROWS. BROWS stands for Baited Remote Underwater Cameras. So BROWS are very easy to make. You can make one for yourself, right? It's all it needs is a weight to keep it down, a GoPro, a stick with a bag of bait. Could be paakellak enna puluwan, maspetta, and animals will be attracted. So you leave it for an hour or a standard unit of time, and you see what gets attracted. And that's a standard way of surveying for animals underwater. We had one for kids, and they loved it. Like we would put it in the ocean, and so see, this is one way to study sea snakes. But we also recently took it to a much serious level and use an actual submersible. So we don't own this. Australia has 2 of these. This is Kimberley Institute. You can rent these ones. So they do massive expeditions. It's a huge unit, but it goes deep, like deep ocean. So what we did was use their footage to score for sea snakes that lives in the deep ocean. Areas that not has been surveyed, depths that not has been surveyed for sea snakes before. Because these are depths that you can't access with scuba or cameras because the light is not there, right? And what we found is that this is an awesome way to study sea snake that lives in the mesophotic zone. The mesophotic zone is where the light starts disappearing. And in this study we found 2 species that were thought to be extinct from that area, living in much deeper waters that humans don't go. Like what we are doing underwater, we also survey from above water. So drone surveys are very common. Drone surveys for crocodiles. Another cool toy, anyone who has a drone, you can actually use that to do some science. Drones are so common these days. Instead of like on top of your Instagram influencing stuff, you can also use it for actual science, right? It's a standard way of surveying. We do it for crocodiles a lot. But recently we also started using thermal drones. So thermal drones are a drone that you can send at night and it photographs the environment in IR, in infrared. To the level, we can even now detect snakes and where snakes have been. The temperature sensitivity is so high. And the drone we have is radiometric, meaning we can actually measure the temperature of objects on ground from the drone itself. There's a software called Fleur Research Studio, which we use that. So, to sum up, there's invasive species, there's habitat change, there's lot changing, but change is not necessarily bad. Unless you do long-term, properly planned ecological studies, you would not know the actual impact of these things. Now, when you are thinking of change, you have to also think of human use, right? Because human use change from place to place too. If you go to Southeast Asia, if you go to any market in Southeast Asia, you will see hundreds and thousands of snakes for sale, for food, right? In most markets in Cambodia, Laos and Vietnam, you find more water snakes, deer than fish. Because hunting for water snakes is much more common and profitable than selling fish. So we spend a bit of time doing market surveys and also going out with the fishermen to understand how many animals are being caught, how they are caught, and what does that actually do to the populations. And what we see is that it's not actually unsustainable. Like they take a lot, but when you consider how many are out there and how many are reproducing, at least in the places we study, this could not be the case everywhere. The harvesting is actually quite sustainable, but in other places it's not. Like another industry is snake wine. So in Vietnam, if you want Purusha Shaktiya, you have to drink this, right? This is the funny thing is that they actually want to be cobra. So if you put a cobra in wine and drink it, your things work well, right? But the strange thing is that none of these are cobras. They are all deer barriers with their neck stretched. Right? So these are all members of the Xenoprophis genus and sold as cobras. Right? So they'll stretch the neck and pin them, and so no wonder they don't work, because it's the wrong species. Now, Sri Lanka also have something similar, right? Like, what's this species? What snake? Madapanua redinaya, the most pathetic snake of all snakes. Right? Can't bite, can't move fast, can't pretty much do anything. If you put it there, it's going to be there. So these guys are being caught in nets in hundreds in places like Kalpiti and Puttarama, in the lagoons. This is a system I really love to study. Understanding the impact, understanding the seasonal changes. So anyone interested in something like that, love to be a part of that. Because understanding the level at which these animals are being taken out is very important. In a recent trip to US, I was catching salamanders. Now these are cool things, right? You never see them in Asia, or Asia has 2 species, but Australia don't have any. So something very cool to play with in America are salamanders. And they are fairly common. Like if you go to the right places, any rock you flip, you get salamanders, right? And while we were sampling some salamanders once, a truck came, stopped there, few people got out and got a bucket and flipped few salamanders into the bucket and drove away. So when I asked my collaborators, what's that for? They're like, oh, that's for fishing. So in most parts of northern, like in USA, you can get salamanders, put them on a hook live and go fishing, and it's completely legal, right? It's completely legal. And there has been studies over the years showing that their salamander numbers are doing extremely well, and that won't even have an effect on their population. Now, regardless of the sustainability, I don't agree with things like that. Animal ethics is quite different to sustainability, right? But my point is that we are still lacking in that space. These are areas that we can improve to understand actually what these populations are doing out there. Now, if you go to the other part of the world, in Australia, the best example are crocodiles. Till 1970s, crocodiles were shot left, right and center. So many crocodiles were killed to the level that they became almost extinct in the wild. In early 1970s, the Australian government made crocodile hunting illegal, but completely supported farming of crocodiles for commercial purposes. Now there's so many farms, especially in northern Australia, where over 100,000 crocodiles are being bred annually. So all these are captive bred eggs, and they provide for the commercial market. And quite a lot of scientists, including myself, work with these farms to get quite a bit of ecological information, because you cannot get this many crocodiles in one place, right? Now, these programs were so successful that crocodile numbers now in Australia are more than what it was before hunting. To the level, it's actually affecting elsewhere, right? So recently, a few years ago, there was a massive increase in crocodile attacks and crocodile sightings in Timor-Leste, which is up there. It's the latest country in the world, East Timor. I've actually been there. It was a war-torn country. There was a Sri Lankan peace force there, and I think you have worked there, or going there, right? So it used to be part of Indonesia. Now it's an independent country. When we did the genetics of the crocodiles in Timor-Leste, we found that all those crocodiles are from northern Australia, right? So crocodiles in North Australia the population is so big, they're running out of space. They are doing transoceanic swims across the ocean to go to another country, right? We saw a similar trend in another system we are studying on sea snakes. Now, sharks are one of the biggest predators of sea snakes. Shark studies in many parts of the world, especially reef sharks and tiger sharks, have seen that they pretty much some populations almost exclusively feed on sea snakes. Now, a system that I was studying in Ashmore Reef is a very interesting place where in 2000 we saw a huge decline in the sea snakes. So the bars are sea snakes, right? Over the years they have been surveyed, and we see by about 2000 there was a huge decline in sea snakes. But in 2000, around 2000, shark fishing was also banned. Like people could go there and fish for sharks before, but that was banned. And what we see is that since 2000, there's a huge increase in shark numbers. Right? So conservation of one species sometimes can change the status of another species. Again, only long-term studies like this would tell you so. That goes to our last part. Listen to the locals. Right? Now, this snake, Acipurus apifrontalis, was doomed extinct. In Australia, scientists, including myself, declared it extinct because for over 50 years we have not seen it. Right? We have not seen this species in Australia. So it was only known from one place, Cartier and Ashmore Reef. We did not get specimens for over 50 years, and according to IUCN, if you don't see something for more than 50 years, it's extinct. Right? So it was doomed extinct. A few years ago, I was invited to give a talk for the fishing trawling industry, where in Australia, when you do fishing trawling, all the bycatch needs to be recorded, your turtles, your sea snakes, your whatever other things you catch. So we ran workshops for people to identify sea snakes so they can actually record the species. And I mentioned about that thing, saying that there's a sea snake, it's extinct. And a couple of these guys, they're mostly Filipino fishermen, they're like, nah, what extinct? We caught like 2 last night. What extinct? This is right? And I was like, yeah, I'm a scientist, I know. They're extinct, right? And they were like, nah, every night we catch them. And then I was like, all right, I'm in town for 2 more days. If you catch any tonight, bring me to the hotel tomorrow, right? I found out. Next morning, they come up with this tub. And 2 of those are that extinct sea snake. This is a typical example, this is a typical scenario with a lot of scientists, right? We think that we know better. It's very common because we sample. Scientists go out for like once a year for a place, and if you don't find it, you think, oh, it's rare. Right? There are people who live there their entire life. Talk to those guys. Right? It's very important that we use citizens or use the local knowledge in what we do. So we use this. I went back, talked to many other fishermen, found all the locations they think exist. We went to the museums, checked all the records of these species, and we did what's called maxent modeling to understand where other species can occur, right? And we then went to some of these places, especially for apifrontalis, and we found 2 new populations of these guys, simply because of these maps that we developed depending on fishermen's ideas. And we actually found new to science, but not to the locals, they knew it all the time, populations of these so-called extinct sea snakes. The same happened for another species that I really wanted to study for a long time. We knew that there's a snake out there, it's called the Irabu sea snake, Irabu sea crate, Hydrophis semifasciatus. We knew that it's the only species that hunt in packs. Imagine a snake that comes in packs and hunt together, right? And I've been looking for a place to study these. One time, just talking to a fellow diver, the diver was actually showing me photos of have nothing to do with any animals, he just loved diving, right? He was like, oh, look at the snake I found, right? I was like, that's the one I'm looking for. And then, based on that diver's place, like the one thing that he said, we now have a project looking at these guys in the deep waters of Lombok. Right? So, that sounds like it's supposed to be something. I'll let it pass. So these guys comes as a pack, right? And a pack of up to about 30 to 20 animals. Some of them will flush the fish, the others will eat them and they take turns. the only and the first record of snakes having coordinated hunting, and we just published that. And some of them are very curious, like this dude. So he was very curious about my reserve line. It's an amazing system. It's so deep. It's 40 meters. All our team had to do deep diving certification, and it's just in middle of nowhere in an island called Lombok, and that was completely based on just talking to a fellow person who had nothing to do with science or reptiles, but gave an idea. You know what? This is where you have to go. Right? So the moral of my story is that regardless how specialized or how good you are, listen to other people too, especially listen to the locals. And to be honest, that site is actually amazing. That's like the non-sampling time. It's on a pool. Right? It's a pretty cool gig. So over the last 2 decades, 15 years, I have actually had the chance of doing herpetological work of any nature or some nature in about 16 countries, and consider myself absolutely privileged to be able to do what I did as a hobby, as a kid, as a career now, right? But one thing I realized with all this, like working with other communities, other scientists, other parts of the world, is that a lot of these things, we have it in Sri Lanka, right? We need to tap into that. There's a huge knowledge gap when it comes to ecology and conservation of Sri Lankan reptiles. Nothing unusual. These are done elsewhere in the world, so it's not impossible. It just needs some motivation for people like all you to start some work on ecological work. And that's important because a global survey which quite a few of us were part of showed that 1/5 of the 11,000 reptiles in the world are threatened with extinction. And we know absolutely nothing about another 1/5. So there's so many species out there that we have absolutely no clue apart from the fact that they live, right? So this is where young scientists like you guys can come in. As students, start publishing. Your publications are your currency for a future in this field. There are so many journals now encouraging people to publish opportunistic observations. You don't need to go on scientific expeditions or do long-term research. You can publish what you see. Things like herpetological review is a good start for that, right, if you are in herpetology. There are so many apps where you can contribute to. iNaturalist is a good one. Sanjay, you do fair of that, right? Yep. And if you don't have it, install it today, right? It's such a good way of how you can contribute to the world scientific community. If you see an animal, put a record of that. If you don't know what it is, there are specialists who will identify it. And it will put a dot on the map. So when you do conservation assessments, when you do distribution mapping, when you do like global scale studies, all these can feed in. There's a huge demand now for data on distribution of species because we need to know where things live and how they are affected. These are ways you can contribute to. And living with reptiles in a changing world is a must. It's unavoidable. No matter what you think, there's not going to be pristine environments everywhere, right? What's going to happen is that we have to accept the fact that the world is changing, animals are going to adapt, and we have to adapt to live with them. So the more we know, the better we can deal with it and also help save these species. With that, I'm going to stop. Those are my contact details. All the work that I just spoke about and more are on my website. You can download all those papers. And if anyone has ideas that you want to follow in herpetology, in an ecological or conservation point of view, very happy to discuss in future. Thank you.
Guys, what we're going to do, thank you, Ruchira. It's awesome. And we'll have a big question and answer session. Again, language का बाधा नहीं में
किसी से बाधा हो गया